Okay guys, this is 7.4. It says, what is the product of 12 and 4.2 expressed in scientific notation? Really what you want to do is multiply your 12 and your 4.2 first, which will give you 50.4, and then times 10 to the 6th power. Notice that that's actually one of the answers. However, that's the trick answer because it's not written correctly in scientific notation. So what they did is they moved it over 6 places when really, instead of 6 places, they should have gone to 7 places. So it's 5.04 times 10 to the 7th power. So be careful with that because they're trying to trick us. It's correct, but it's not in scientific notation, and the directions ask for that. That's the way you have to leave it. Okay, we're looking at more multiplying properties of exponents, which is Chapter 7, Section 4. Raising a power to a power. To raise a power to a power, you're going to multiply the exponents. The rule is right here. So if it's am raised to the nth, it's really just m times n, which is a to the mn. Think about it. This, if I was to work it out the long way, it would be 5 to the 4th squared would be 5 to the 4th times 5 to the 4th. You learned that when you multiplied, you added the exponents. Or you can use the power rule and know that 4 times 2 is 8. Okay, so when you add them, for example, let's do a quick review on this. When you add them together, or when you multiply them together, like let's do x to the 5th times x squared. When you multiply, you add the exponents. When you divide, you subtract the exponents. And when you raise a power to a power, you multiply the exponents, which is not 7. Let's look at some examples. If I have x squared times x to the 6th raised to the negative 4, first thing I'm going to do is use the power rule to get rid of my parentheses first. So I'm going to multiply these two and get x to the negative 24th. Now I'm down to multiplying. As long as the bases are the same, I can use the rules. X to the 2 plus negative 24 is negative 22. Cannot leave a negative in your exponent, so you're going to take the reciprocal of it, which is 1 over x to the positive 22. Second question. Power rule again is right here. So we have w to the negative 2 times w to the 7 times 3 is 21. You're now multiplying, which means you add your exponents, and you get positive 19. Third example. Power rule is right here. So we're going to have r, negative 5 times negative 2 is a positive 10, times r to the 3rd. You're multiplying, which means you now add. Make sure you guys are putting me on pause, trying one, and then having me continue. Raising a product to a power. This is where you have more than one digit or variable within the parentheses raised to a power. Notice what's happening here is this 4. There's really an exponent of 1 here and 1 here. So it's 1 times 4 is 4. 1 times 4 is 4. 3 to the 4th is 81. And x to the 4th is 4th. A lot of kids think it's like distributive property, but it's not distributive property. It just seems like because you're applying to both of them, that's what it looks like. The 7 has a 1 on it, so you have to multiply. It's 7. 1 times 3 is 3, and then m, and 9 times 3 is 27. So now we do 7 to the 3rd power, which is 7 times 7 times 7, which is equal to 343, m to the 27th. Final answer. Question number 2. It's a negative exponent, so first thing I'm going to do is I'm going to reciprocate it. Keep it in parentheses because The -4, which now is going to go to a positive, applies to this and this, which means I use the power rule. 1 times 4 is 4, and 1 times 4 is 4. So now I'm left with 1 over 2 to the 4th power is 16, z to the 4th. The last one, it's kind of cut off. It's to the -2nd power. So I have 3 to the 1st, g to the 4th, raised to the -2. I'm going to reciprocal to make it a 3 to the 1st, g to the 4th, getting my outer exponent to be a positive. And now I'm going to use the power rule. 1 times 2 is 2, and 4 times 2 is 8, and 3 squared is equal to 9.
Coach Nettle.
So we end up with g to the 8th. So let's go ahead. I'm going to have you guys try these on your own, and then after you do them, go ahead and have me speak again, and we'll go through to make sure we got it right. Okay, let's put a 1 in all the imaginary exponents. So I have 3 to the 1 times 4 is 4, x to the 1 times 4 is 4, and y to the 5 times 4 is 20. 3 to the 4th is 81, x to the 4th, y to the 20th. Sometimes they leave it like that. They prefer the higher exponent to come first, though it's not the end of the world if you leave it the other way. This one has a negative exponent, so the first thing I'm going to do is going to take the reciprocal of it, making sure I don't lose my parentheses. And I'm going to put in my imaginary ones for the sake of teaching, and then apply the power rule. 3 to the 1st, which would be 1 times 4, b to the 1st raised to the 4th would be to the 4th, and c to the 5th raised to the 4th is c to the 20th. So that's going to give me 1 over 3 to the 4th power is equal to 81. Putting my higher exponent first would leave me with an answer of this. The next one, my exponents are all 1s within my parentheses, so the power rule is going to give me 6 to the 1 times 3, a to the 1 times 3, and b to the 1 times 3. 6 to the 3rd power is 6 times 6 times 6, which is 216. A to the 3rd, b to the 3rd. And that will do it. That was 7.4.